Okay, let's get started with something a little bit new. Actually, today is going to be a little bit of a review. It's going to be a review of some stuff that we did in pre-calculus. So please pay close attention to the stuff that I'm going through, and hopefully we'll start to remember all of these things and kind of what's happening. So the first thing we're going to do is we're going to start to review these ideas of rational functions and how rational functions work. So let me present my screen to you. So here's my screen. You should see just a blank sheet of paper. So we're going to get started. These are the notes for September, I think it's 21st, 2020. Okay. And what we're going to do is we're going to talk a little bit today about rational functions. Okay. And mainly what we're going to work with is we're going to work with this rational function. So everything is going to start using this function. F of x equals 2x squared minus 12x plus 16 over x squared minus x minus 12. So what we're going to do here is we are going to do some of the math to algebraically determine a few key things, and then also draw the graph of it. So what we're going to do is we are going to graph it. Okay, so first of all, let's kind of start with a couple of things. Most rational functions will have some possible issues. They could have holes in the graph. They also could have some vertical asymptotes. So we need to remember how to find those things. So what we're going to start with first is we are going to find the quote-unquote holes and vertical asymptotes. Now, it all kind of involves doing the same thing. So the first thing that we have to do is we have to go through and we need to, looking at this right away, you should be thinking, I need to factor this so we can determine, if anything can cancel out or things like that. So let's first of all start with some factoring. So let's start with just the numerator. So you can notice in the numerator, the first thing we can do is they're all divisible by 2. So let's take the 2 out, and that'll give us x squared minus, oops, I forgot the x, minus 6x plus 8. Okay, so we have x squared minus 6x plus 8. Now, I'm just going to go through and I'm going to factor things just one at a time so we can just focus on one thing. So I'm just going to put the minus x minus 12. So that's our first step, is let's take that out. Now, our second step, and we're just going to kind of keep going down, is our second step is we need to factor the things that are left. So you need to kind of remember how we go about factoring things. So what my suggestion is to factor things using the guess and check method. Okay, so we're going to factor both the numerator and the denominator the same way. Okay, so let's start with the numerator. So focus, first of all, focus on the x squared. So you'll notice right here we have x squared. So that x squared we have to split up into x and x. Now, the second thing we have to focus on is let's focus on the 8. Now, remember, when we focus on the 8, you need to be thinking what times what gives you positive 8. But it needs to add up to the number in the middle. So it needs to add up to negative 6. So in my head, I'm thinking 4 times 2 is positive 8. But 4 plus 2 equals positive 6. But what if I use the negatives? What if I said negative 4 and negative 2? So negative 4 times negative 2 is positive 8. When you check these out, what's negative 2x and negative 4x? When we add those up, you get negative 6x. So that is my factored form for the numerator. So let's do the same thing with the denominator. Okay, let's start with our x squared and let's split those up. So x squared is split into x times x. And now we need to think about this negative 12. Okay, so what times what gives you negative 12? But it needs to add up to the negative x here in the middle. So I'm thinking in my head, negative 4 and positive 3. So if I put negative 4 here, and I put positive 3 here, and I check, so multiply these together. Negative 4 times x is negative 4x. X times 3 is 3x. When you add those up, negative 4x plus 3x gives me negative x in the middle. Okay, so all of those are factored. Now, once you have this information, there's a couple of things that we need to remember, okay? The first one is A. Let's do little a, okay? Where are the holes? Okay, so where are the holes? Remember, graphically, a hole simply is something that just doesn't exist. So the line kind of moves along, but there's just a simple space there. Holes exist in these spots. It exists in the spots that are canceled out. So when you can cancel out a set of parentheses, the x value to make it equal to 0 is where the hole is. Okay, so let's look at our factored expression. If we look up at our factored expression, what part can we cancel out? Well, we can cancel x minus 4 and x minus 4. So x minus 4 is canceled out, but we want to know where does that equal 0? So the hole is at x equals 4. Okay, so the thing that cancels out is the place where there is the quote-unquote hole. Okay, so but please make sure that you set that thing in parentheses equal to 0. Now, the second thing is, where are the vertical asymptotes? Okay, now remember, vertical asymptotes on a graph are places where on one side the graph might go up, and then on the other side the graph will go down, and there are these spaces where nothing exists. Okay, so where do those occur? Well, those occur in the parenthesis left in the denominator. So if there's anything left in the denominator that isn't canceled out, that's where the hole is, or the vertical asymptote is, I'm sorry. So take a look at our equation. What is left in the denominator? We are left we have x plus 3 is left in the denominator. Now, you do need to remember, it's the place where x plus 3 equals 0. So what value of x will give us, okay, what value of x will that be or give us 0 at? So we have x equal to -3 is where your vertical asymptote is for this problem, okay? So these are the first two things that you need to know how to calculate. So we know where the holes are. We also know where the vertical asymptote is. Now, along the side here, I'm going to just review one thing, okay? Because once you figure out where the holes and the vertical asymptotes are, you can define your domain, okay? And if you remember, the domain are the x values that quote unquote work for the function. So they're all the x values that work, not the ones that are undefined or are holes or things like that. So in this case, the domain will be all real numbers except two values. X cannot equal 4 and x cannot equal -3. So remember, the domain are all of the x values that work. Okay? So, and it is defined based off of whether you have holes or vertical asymptotes. So, this is our first thing that we need to review, calculating these things. The second thing we have to review, and we're going to keep using this same function, is we need to talk about what the